Long. They call me CPTBadAss on Keycaps.
You named yourself.
Who actually calls you?
I've been called Cadet New Ass for a long time. I was demoted a year ago. So yeah, next slide please. No, that's not next slide. You got to do page up and down apparently. Alright, cool. So in my day job, I'm a mechanical engineer at GE Aviation. That's the last engine I worked on. If you fly in 2017 on a Boeing 737, you'll be flying on something I worked on. I only say that because I do know metals, but the problem is the last like 3 years of my actual work life, I've been working on like aerospace stuff. So a lot of it is like really high-end metals, or really like things like anodization and stuff. We don't do as much of, even though I should know more about it, but. We focus on a lot of other things. So if it seems like my knowledge is kind of off, that's because that's what I've been doing. And I helped with the Tech 80, and I've also done some other stuff on the forum. So I think Beast had a 60% case that I helped work on, but that hasn't come out yet. Anyways, next slide. So I'm giving this presentation because this is the only thing I feel like I'm qualified to give a presentation on. And there's a lot of like keyboard cases out now that have they're made out of metal, like the Tex is out, all the Korean customs that are out. Actually, I need to grab those. Can someone grab? I gotta go grab my keyboards, or I can show them off later. But they're all made out of metals. The springs inside are all made out of metal. The plates that we like, the custom plates with the fun cutouts, they're all made out of metal. And a lot of it is just they essentially come as raw materials, and then they're cut or shaped in some way. So like a case is probably milled somehow, either CNC or manually. Plates are probably laser cut, water jet cut, or milled. And the springs are most likely a CNC machine, but you can actually coil them yourself if you really want to. It's just a pain in the ass. Next slide. So where are we using them? Like those titanium keycaps. This is aluminum 6061. It's a K-Mag LE. But the top of the case, bottom of the case, the plate, the feet, that's all metal. Your springs, obviously, the plate that's in here. If you guys saw that small fry keyboard out there, that's all titanium. It's cool. So yeah, next slide. So what is actually, I mean, you could just say metal and people just assume, oh, it's just stainless or whatever, but it's actually, there's a lot of different forms of them. So metals it's essentially minerals or dirt that you find in the ground that you refine to make into a material like that. And you find a mine, you get the stuff out of the mine, you smelt it or melt it into something in there, and then you pour it out, and it'll become, they'll probably pour it out in billets, or they'll probably pour it out in like a larger shape that you then take to make into a smaller shape. Most of the metals that are used in keyboards are going to be alloys, so you're not using pure copper, you're not using pure brass. They're going to be aluminum, which is a mixture of manganese, silicone, and aluminum. And the plate is probably, I think the plate that I brought is aluminum 3000 of some sort, which is aluminum with manganese, or 5000, which is aluminum and magnesium. Next slide. So, I think there's something else. Can you
press up a little bit?
Yeah, or press down a little bit. Okay, it's fine. So, the alloys then you get them into your billets, or you get them into sheets, or you get them into like bar stock, and then you'll machine them down to something else. And what makes all the grades of alloys and metals different is what makes up the chemical composition and how you heat treat and post-process them. So for example, if you look up 6061 in Wikipedia or like a material spec sheet, it'll say like 6061 T6, which I think this is T6, or T4 or whatever, and it's how they heat treat it afterwards. So the whole point of doing this is you want to give the metal some form. You're aiming for different properties in the metal. You want it to be You want it to resist corrosion a little more. You want it to last a little more. You want it to be able to handle a little higher temperature when you do your secondary processes. You want it to have better welding. Whatever it might be, you're looking for some property in that metal. So you might need a different heat treatment. Like maybe T4, it doesn't weld as good as T6 or whatever the case might be. So next slide. So like I said before, you're looking for material properties, and these are just an example of some of the material properties that you're looking for. Things like what we might care about is hardness. So some of the hardness specs over here, or the modulus of elasticity. So if you've ever seen that picture of a photoelectrics LZ, where it was straight and then it was bent here, obviously someone managed to find sorry, I just blanked the modulus of elasticity. So, I mean, there's all these specs, and then there's other specs that you're looking for, and again, it's just what's the application of the metal, how do you want to machine it, and what's really what it is what does the metal need to do when you're done with it, and that's what all these specs really govern. So next slide. So like I said, how do you get all these properties? You have raw properties to begin with, so you're not going to use gold in a keyboard case. Too pricey, too soft. You're not going to use brass for it. It has corrosion issues. You can do aluminum because it's cheap, but you have to finish it because aluminum has corrosion issues, which is why there's all those debates about anodizing and whatever. That's why.
Can you get corrosion from sweat?
Actually, yes. Yeah. I have really sweaty hands, so a lot of the tools that I have, if I don't wipe them down, and if they're cheap, you can see where they start to corrode. Yeah, it's bad. But anyways, you can also get material properties from that refining process. So if you pour it into a crucible, the crucibles have tons of different setups. You can throw a current through them to melt it. You can just put heat in there to melt it. If I put recycled aluminum, like your aluminum cans, in versus raw aluminum, you're going to get different properties out of there because you don't know what impurities are in your recycling. When I heat treat the materials inside, there's little grains. Like there'll be like a little bit of, manganese, and how is that manganese aligned with the next piece of manganese inside will determine, like, is it going to be good in tensile, or is it going to be good in compression, or is it going to have a good property, like whatever property you might be looking for later. And then things like forming. So like, if I take a sheet and I bend my sheet, I've introduced some compressive stress and some tensile stresses. And how does that affect me later? Maybe that point is going to be weaker. Maybe I've introduced a weak point. And then you can do like mechanical treatments, like shot peen. So you can introduce different properties based on how you surface treat that metal later. So I'll be talking more about shot peening on this later. So like I said before, these are how I think most of these parts are made. There's probably other ways to make them, but this is like, if someone came to me and asked, oh, how would you make a case? This is what I would say. So if you're making a case like this, the case in here, it's just hollow. Like there's like a depression inside where the plate and all the switches can sit into. This is most like, I think I know this is CNC milled. I think I've seen pictures of them on Keycap, but it's milled in some way. The plates are typically laser cut, water jet cut. You could mill it, but it's not a very effective way of.
Also stamped.
You could stamp it, yeah, you're right. You're right. But then after you stamp it, you could stamp out all the holes too. Yeah, you're right. Springs are either CNC spring coiled machines or specialized machines that make springs. I have a video of it later. You could hand make it. I think Ming was saying, like, if you really wanted to experiment, you could take a dowel and some music wire or piano wire and just start making your own springs. They won't be consistent, but you can experiment a lot. And then inside the springs, they have those little leaves. So like, if you've seen the Alps stuff open, or if you've seen how the cherry switches inside, they have those like little springs inside. Those are probably stamped.
Stamped and then bent.
And bent, yeah. There's two processes, and they're probably heat treat. So I'm assuming that
They're
there's
plated, right? Because they're gold.
Yeah.
Yeah, they're
Photek.
plated. Yeah. So I'm going to talk about some of the processes. I've got some videos and pictures. So all these processes really are, how can we get this humongous billet that may be the size of this room into a smaller size, into a size that you can manage, and then I can mill it or hand finish it or whatever. So what I wanted to point out was that when you say CNC, it's computer numeric control. So that means the computer is controlling something. So if I have a Dremel and I'm dremeling something, I'm manually holding that to Dremel things out. If you have a CNC machine, that means that there's a computer arm that's holding the CNC or the Dremel, and it's dremeling things based on the code that I gave it. So a lot of times when I see things like manual CNC, that's like a contradiction because you can't really have both. Next slide. Okay, so you guys seen the Independence Day movie? The spaceship is above the White House, and it shoots down a humongous beam, and it destroys the White House. That's really what water jet looks like. If you hit play. So you can see that there's this arm here, and the arm has this, the arm shoots out water, and the water is actually cutting the metal. And so it looks like the Independence Day movie. You're cutting out this hole right here, and it's going to form a path, and I think in this case you're cutting out the company logo. But yeah, so when you do lasers, it's very similar. It's going to be, instead of using water, they're going to have mirrors that direct your laser into the part, and then you're just going to, again, cut this out. And water jet will have things like, they'll put media into it, so like sand or whatever, so that you get more abrasive properties, so you can cut this. And yeah, I'll let this run for a little while so you guys can see what happens. But it happens in a pool like this. You put the part in there. So if you're worried about corrosion from the water with your metals, you're going to have to do a secondary process to clean up all the water so you don't get more corrosion introduced. The bad thing about this is because even though it looks like it's pretty well controlled, there's actually something called kerf, and that's how much overspray there is beyond that nozzle. The machines have gotten better, but you still have to watch it, and the tolerances typically aren't as tight as laser cut stuff. But I think water jet can cut thicker than laser, but that's off the top of my head. Pretty sure. Okay, we can stop the video. Oh, actually, this might be useful. Well, I have to. Yeah. So you can see that they're programming this into the CNC machine. They have a path drawn out in the part. Like, this is their logo, and that head is following where, when he's moving his hand, what he's following, it's following that cursor. So, you can do things like, you can partially cut it and inspect the cut. You can, I'm pretty sure you can pause it and change the CNC on the fly, even though they don't really like that, but this is how a CNC program might look like. This is as opposed to like if I would just take like a hose and start holding it and went like this to cut my hole manually. And you can know how to stop it. And then next slide. Yeah. So like I said, the laser is the same thing before, but instead of having like the water come out, you're gonna have a laser come out, and it has the same thing. This is like a cross section, so you can see how the inside works, and it's essentially the same thing. There's going to be lasers that come in. There's gases that shield that laser so it doesn't have a kerf and it doesn't spread too much, and it focuses the energy where you want it. The other thing with lasers is you got to pay attention because you're introducing heat into the area, and that heat later might change the properties from what you want to something different based on the heat affected zone in here. So next slide. So milling is really easy. If you've seen a Dremel, that's essentially milling. If you've ever used a Dremel, you hold it down, there's the spindle and the bit, you hold it down and you make whatever. That's how milling works, except it's on a way bigger machine. So I think it's the third. We can play this. This is what the laser looks like, and then I'll go to the milling. And of course, because it's a machine shop that they don't really know what they're doing, there's like the world's most epic music. Oh wait. Okay.
This is CNC.
Sorry, this is CNC. I thought I had a laser video, but I don't. So, oh wait, go to this.
Go back.
Go back. Here.
You
To the second video.
You're on the right.
Yeah. So this is a CNC milling machine, and this is 6-axis. So you can, if you hit play, you can see all the axes that this can move in. It's pretty crazy. I love watching this stuff whenever I ask for machining porn. This is what I want to see, but nobody's ever shown it to me yet. It's really cool. You can get really, really, really intricate designs. The problem is these machines are pretty expensive, so they don't want to have like me come in and say, I want to make this case, and I only want to make 20 of them. They want to make like aerospace parts because GE has deep pockets, or somebody has deep pockets, and they're going to make thousands of them and work with them for years and get their money's worth. Because of one of these machines, I think the guys were saying like third hand was still $500,000 or $250,000, and then you have to have coolant sprayed in here. You'll have to pay the guy to code. You'll have to have a mechanic because that'll break. You'll have to do like all this kind of stuff. So they want to have their money's worth of the machine that they just bought, and to not only pay back the machine, but to try to make some money off it.
When you're programming the 6-axis CNC, are you using a 3D model or are you?
Yes, typically they'll either take the 3D model that we give them and then program it into their thing, or now that a lot of them, you can just give them a model and the machine will parse the code out of that model and then know how to machine it. So it's pretty cool. So if you hit the Bridgeport right there, and you skipped, I think it's like 2 minutes. Yeah, right there. And then hit play.
And it's really bored, it's gonna...
See, so now you can see that some guy is now standing here cranking handles and
this machine back
this
here was
move
done in
around.
1966.
So if you hit pause,
Yep.
this is a Bridgeport. Apparently, this guy says you can get it for $500, except it costs $1 million to move it. This is like my favorite mill that I've ever worked with. We had him at school. And it's the same thing, except as you can see, there's only 3 axes on this. This will actuate this way. This will actuate this way. Oh wait, it's 2 axes.
There's up and down.
There's an up and down. There's
right.
the translate, and then there's whatever this in and out. This axis here, so it is a 3 axis, right? And so you put your part here, and you move the part up towards the cutting head, and that's how you form parts. So like if I had my keyboard tray like this, I would move it up, cut it out, or cut out what I want, and then move it back down to see like the inside of this case. All right, so back to my slides. All right, next slide. For cases, you can also do casting. If you guys ever played with like, you go to a cheesy party and they got that like Jello mold thing that they serve.
Jello shots.
Jello shots too, exactly. Jello shots, Jello molds, things like that, right? Anything Jello related, you can pour it into your shot glass. You make like those weird Jello fruitcake things, and it looks like the Jello fruitcake bowl, and you can see like the logo in there.
Oh, like with the stapler?
Exactly. Yeah. So essentially what it is you pour Jello or your molten metal into this thing, right? And this is a negative of whatever part it is. And
Wait, did you just announce a Jello keyboard case?
Yes.
Okay.
2015 Jello keyboard case. First on Keycaps. So, yeah, you pour your whatever into your mold, and this is also for Keycaps. You pour it into the mold stats, and then you pull your parts out. Pretty easy if you know how Jello and Keycaps work. And, yeah, I guess you heard it here first.
So when Jacobs talks yesterday, he said that some types of switches don't work in water. Do they work in Jello?
We're gonna have to run experiments. I think that we're gonna have to bring some Jello.
So probably they would, because the explanation is that radio waves.
Will the acoustic one work in there? Okay.
Yeah.
So for the springs, you're gonna have this goofy spring forming machine. If you were a kid, you played with Play-Doh. You have the thing, and you ram, you push something through, and the Play-Doh comes out, and it comes out in like a star shape or whatever.
Extrusion.
Exactly, extrusion. So when it comes out, all these arms will form that wire into something. So if you play, I hope they zoom in. If you can see it, it comes. They have a wire come out, and then all these arms here will form that coil, and then this arm will bend it, or you can cut it. But these are specialized extrusion machines. They're pretty much only for wire forming. They're really common in like the automotive industry where they have tons of springs. You can also do this same exact process on the dowel. You have some wire, you wrap it around the dowel, you cut it, and then there's your spring. But if you're gonna make like 1,000 springs, you're not gonna do that by hand, or unless you're crazy, or on Keycap, which someone might be crazy enough to do it. But that's what they look like. And this is way, way, way slowed down. Obviously, this would be pumping out like millions a day, but they just slow it down so that you can see what it looks like.
You just pick them up after they're done.
Usually the I think this is, I'm not sure where this is from, but yeah. Doesn't seem like they have a pretty good setup. I think
It's like a mouse trap or something?
I don't know.
Widget with a spring, that's what I'm calling it. And you can just hit pause if you want that. Okay. So next slide. So the leaf springs are either stamped or punch and die. If you made cookies before with the little cookie formers, that's exactly how it works. Your material sits here, you have a die, you come in and you just kind of go like this. But these, it's just, you have a bigger, way bigger, way more force, way bigger hammer, way bigger hand. Like, hand, yeah. They have like 10-ton presses that work, and I've seen bigger ones like 100-ton presses, and they're just massive. What it looks like 2 massive steel plates coming together with like a hydraulic cylinder that's the size of me, just putting tons of weight on. That's all it is. And then they'll do a stamping, and then if they have the bent leaves or whatever, there's probably a second forming process where there's a machine that just bends them into place. Next slide, yeah. Okay, so anodizing, everybody loves to talk about it. That's a post-treatment. If you were following the Tech 80, he did a shot peen before anodizing, so that it wasn't for stress relief or anything, but he liked how the shot peening looked, because the shot peen is essentially you take little steel balls and you shoot it at something, and it'll add a compressive stress layer on here. So for this here, they're going to want that compressive stress because of how these gear teeth work. But Photek liked how that finish looked later. You can also do things like sandblasting, where you just shoot sand at it. You can do media blasting, where you shoot crushed walnut shells at things. Yeah, that's a thing. It's cool. Yeah.
It's not synthetic.
No, they're crushed walnut shells from the agricultural industry.
It has to be walnuts.
For some reason, walnuts works, but I'm sure there's other things as well. But yeah, that's the one I know of. Yeah. And yeah, all right, so next slide. I'm going to talk a little about anodization. So anything you work on is going to have an oxidation layer, everything rusts, everything whatever. So especially aluminum. Aluminum is very susceptible to oxidation.
What about tie?
Yes.
Also, but it's different.
Yes, but it's different. Tie is bad in heat, and I forget the other condition that tie is bad in. But it's not. It doesn't have as high a heat capacity as some other things.
Yeah, burns before it melts.
Exactly. So there's actually, if you guys ever heard of soft versus hard anodization, here it is. When you have a soft anodization, so what anodizing is you're controlling that oxidation layer. And how you do that is, I think I talked about it in the next slide, so I'm getting ahead of myself. But yeah, the soft anodizing layer is less than 1/1000th thick, and the hard anodization layer is more than that. We call these mills at work, so I forgot what they actually stand for. And there's actually a mill spec that governs these. So,
What's type 1?
don't know. I did not look at the mill spec before that. I think this is soft anodized.
The Keycaps are, at least.
Yes.
Because
I
I
forget.
think John's like wore off where his palm rests on it.
It could be, yeah. And I forget what's hard anodized. Now I know the Tech 80 was hard anodized because Photek liked how it looked.
The LZs were.
LZs are? I'm not sure.
No, not all of these. I had a pink one that's hard anodized.
Okay. Okay. And the thing with, because you're controlling that thickness of that oxidation layer, you're also adding material, so you have to be careful with things like screw hole clearances, or like in this plate here, it's got those cutouts inside so that you can bolt the plate to the bottom of the case. those clearances in there, you're gonna have to take a look at and make sure that like your anodization process isn't gonna mess with it. And at work, we use anodization for corrosion resistance, but you can also we do it because it looks cool, and we have a bit of resistance or corrosion issues, but we really do it because it looks cool. So
Otherwise, it's primer, right?
otherwise, it's just raw, and I think there's primer.
So that's just another way to protect it, right?
Yeah.
Primer.
So how anodization works is essentially you're making a circuit where this is either the positive, or this is the positive electrode, and then they send an electrical current that's negative,
Sends the electrons.
and it gets dipped into an acid bath, which is why when people say they want to do anodization at home, I'm always like, I don't know if I want sulfuric acid in a bath, in my bathtubs, but do your thing if you want. And so when that current is sent through, it releases hydrogen and oxygen, and it forms that oxide layer. And depending on how long you leave it in there, is how much that oxide layer will grow, and that's how you get soft or hard anodization. So while you have that acid bath, you can also add dyes into the bath, and that's how we have you have your pink cases, or photoelectrics, LZGH, which is teal, or even this is a color, because aluminum doesn't look like this, but this is a dark gray color. So you can put dyes in your anodization, that's how you get color.
So when they were doing the KeyMac LE, you know, the top shells on a lot of them on the
Yes.
LEs are different colors. Did they switch the batch and like not get the dye correct on the second run, or
They might have done things like
is that the metal?
they might have done things like they run two shifts, and the second shift didn't know that this is the specific dye, so they put it in the tank next to it. I know a lot of the Korean shops are actually like bigger machine shops that actually do industry. So they're probably running 2 shifts or 3 shifts, and they don't know how to do that. Or they might have worked on all the bottoms first, and then dipped those, and then all the tops first, and dipped those, and
different
somehow,
batch, though.
right?
Okay.
I still don't see the difference between the top and the bottom. Like Ellie, you can. Okay. So after you anodize it, go back up. After you anodize it, you still have to seal it so the dye and everything comes in, because when you anodize it, it makes that grain structure be more porous, and that's how it accepts the dye.
Question.
Yes.
So if you look in the case over there, on my
Which case?
the wooden one.
Yes.
I have, that's not paint.
The wooden case that you have isn't painted.
It's aluminum. If you go feel it,
Okay.
it's like an aluminum wood graining.
It's
Maybe go take a look. It's really weird. You know how that works.
probably how I think dye sublimation works, where you can put a screen, like, I forget how they do it exactly, but you can make a finish, and then you float the finish in a bath, and then you charge that bath somehow, and you dip your case in it, and then because of the attraction, it takes on
It's like
that.
screen
It's a
printing
little bit
almost?
like screen printing. Yeah, it's a lot like screen printing actually.
1970s. Wow.
Exactly.
Why?
Yeah, seal it was the last one.
Yeah, okay, cool. So, like we were talking about before, shot peening or media blasting, you can shoot steel balls, you can shoot beads, you can shoot crushed walnut shells, you can shoot sand. Pretty much you can shoot whatever. There's tons of things you can shoot. There was a list that was like 20 long, and I was like, I've never heard of half of this. I don't know why the people doing this, but whatever. And like I said before, it adds a compressive stress layer, and it changes that surface finish. So in my industry, we use it to make sure that you get the exact properties you want out of the material. We do it because it looks cool, and it's also used to change the surface finish. You can change the surface's shape. So if you want to have like a slight depression in one section, you can media blast that out, and you can also use the clean rust and clean the surface off. Next slide. And that's all. So is everybody else have any
Thanks
questions?
for
Listening to my talk. You guys can pass this around and check it out. If you have questions, come find me later or PM me.